Hi, pre-calculus students. We are going to talk about decomposing fractions. All right, so decomposing fractions. So decompose means things that break apart. And so we're going to talk about breaking apart fractions. So if you had, let's say, 4/5, you could think of 4/5 as 1/5 plus 3/5, right? 1/5 plus 3/5 is 4/5. Okay, so basically we've taken the 4/5 and we've broken up into the sum of the fractions that must have given us the 4/5. Okay, that's a very basic idea of what we're trying to do here, but this is way more complicated. All right, so I want to know what are the two fractions that would have added together to give me this. All right, this is a big idea in calculus, and we're talking about it now because we're already dealing with rational functions. All right, so I want to think, okay, what must these two denominators have been so that it will give me this for my common denominator? Okay, so it would be 2x plus 3 and x plus 1. I want the two different denominators I must have had to get to this, because if you think about it, if I wanted the common denominator between these, I would have had to multiply this by x plus 1 to the top and the bottom, and I would have had to multiply this by the 2x plus 3 to the top and the bottom. And that would have given me this. Okay, so that's where that is coming from. I'm being really lazy and not just erasing it. But then when I erase it, I erase what I don't want to erase. So I'm just going to do this. Okay. So now the big question is, well, what must these tops have been to get me this? So what I'm going to do is I'm just going to call this top A and I'm going to call this top B. I don't know what they are. So to figure out what they are, I'm going to do a couple of things. The first thing I'm going to do is in this equation that I have, I want to get rid of all the whole fraction business, like too many fractions. I want to get rid of the fractions. So think about what is a way that I can get rid of all of the fractions. So if I had something more simple, let's say I had this. I'm just making this up. Okay, let's say I had this. And I was like, oh, I don't want all these fractions. What can I multiply through by to get rid of the fractions? And I could multiply through by 8. Because that's my common denominator, right? And if I multiplied everything by 8, I would have 4x plus 4 equals 2, and that's way easier to solve. So I'm going to use that same idea here. I'm going to look at all my fractions and say, okay, what's the common denominator? The common denominator is like this, just this. It's the denominator that I have there. It's 2x plus 3 times x plus 1. Put it over 1. And so just like here, I multiplied everything through by that 8. Now I have to multiply this whole thing here to every single thing. Okay, so when I multiply this 2x plus 3 times x plus 1 to this right here, you see what's going to happen is that the 2x plus 3 times x plus 1 is just going to cancel. So let me just kind of do that off to the side. If I have this here, 2x plus 3 times x plus 1 over 1, and then I multiply by this right here, 15x plus 19 over 2x plus 3 times x plus 1. These are gone and these are gone. I'm just left with 15x plus 19. Okay, but then I have to multiply this by this. Okay, when I do that, so now I have, let's just erase this. Way. Now I want to multiply that times a over 2x plus 3. Well, now this goes away and this goes away, and I'm left with a times x plus 1. Right, then I have to multiply this whole thing by this. Okay, so when I do that, let's go over here where I have a little more room. So when I do the 2x plus 3 times x plus 1 times the b over x plus 1, now these are gone. So now I have plus b times 2x plus 3. All right, so first I figured out my denominators, then I'm trying to figure out the a and the b. To do that, my first step is to get rid of the fractions. Okay, now I look at this and you're like, great, I've got 3 variables. I've got an a, a b, and an x, and I want to know what a and b are. So what I'm going to do is I'm going to create a system of equations. To create this system, I'm going to focus on first my x terms, so a times x and b times 2x, And then that would have to equal, so a times x plus b times x would have to equal 15x. So I'm going to set up a system. All right, a times x plus b times 2x equals the 15x. Okay, so this first equation here that I'm going to use is coming from these. All right, now my next equation, because I'm trying to write a system here, let's do this, is going to come from doing a times 1 plus b times 3, and that's going to equal 19. That's going to give me the second equation. So I have a times 1 plus b times 3, and that's going to equal 19. All right, so now my system is I have ax plus 2bx equals 15x. I'm just rewriting it. And then I have a plus 3b equals 19. And I want to solve this system. Okay, you can use elimination or substitution. I'm going to use elimination, right? Because I see if this is an ax and that's an a, if I multiply by this by a negative x, then I would have a zero pair. I would have opposites. So I'd have negative ax minus 3bx equals negative 19x. And here, I'm just going to leave that. So I'd have ax plus 2bx equals 15x. Now, the reason I did that is these are opposites. So that's gone. Here, I would have negative 1bx equals 15x and negative 19x is negative 4x. And if I divide by negative 1x, I get b, because remember I'm solving for a and b, is 4. Okay, now I also want to know what a is. So the whole point of this, if we go back up here, the whole point of this is to figure out my a and my b. So right now I know the b should be 4. I need to know what the a is. So I'm going to go back to this system right here, and in place of either here or here, it doesn't matter. You can do it in either place. I'm going to put 4 in for b. So I have a times 1. So a plus 4 times 3 equals 19. So a plus 12 is 19. So a is 7. All right, so now the grand finale here is to say that 15x plus 19 over 2x plus 3 times x plus 1 can be decomposed into two fractions. 7 over, what was it again? 2x plus 3 plus 4 over x plus 1. So the idea is if you were to get your common denominator here, right, multiply this by x plus 1, x plus 1, and this 2x plus 3, 2x plus 3, it would end up equaling that. All right, let's look at one more. So 311, which is the same idea, but just another one. Okay, so if I were you, I would hit pause on the video and I would just first do it myself and then check and see. All right, now this one a little bit different though, because it's not already factored. So we would factor that first. So we would say this is equivalent to 29x minus 5 over, if we factor this, it's 3x plus 1 times x minus 7. Okay, and then the same thing as before. What must the two denominators have been? So that would be 3x plus 1 and x minus 7. I'm going to call this a and this b. I'm going to multiply through by my common denominator. And my common denominator would be, and I'm just going to do it on this side because I don't have a lot of room, would be 3x plus 1 times x minus 7. And I'm going to take this whole thing here, and I'm going to multiply by each thing. Okay, so when I do this times this, it's just 29 x minus 5. And I do this one times this one, the 3x plus 1's cancel. So I have a times x minus 7. And I do this one times this one, the x minus 7's cancel. So I have b times 3x plus 1. So then I would have 20. So now I'm going to write my system, right? So the ax and the bx, or the b times 3x, equal to 29x. Okay, so I'm going to write it. I like my variables, my a and my b on the left. Okay, so I would have ax plus 3bx equals 29x. And then I would have the negative 7a and the 1b equaling the negative 5. So then I would have negative 7a plus b equals negative 5. All right, now if I eliminate the A's, like this one needs a -7 and that one needs an X, so I'd have to multiply the top and the bottom, and you can totally do that. I think the B's might be easier because I could get away with just multiplying this bottom equation by, I need a -3 and an X, and then I don't have to mess with the top. Okay, so I'd have AX plus 3BX equals 29X, and then I would have 21AX minus 3BX equals, why can't I think, 15X. Okay, so the whole reason I did that is now these are opposites. So then I have 22, because it's like having 22AX equals 44X. And then if I divide off this 22X, I get that A is 2. A is 2. Now I'm going to go back to either one of these equations to get B. I think I like this one. I'm going to put the 2 in here for A. So I'll have -7 times 2 plus B equals -5. So -14 plus B equals -5. So B equals 9. So then going back up to here, and I'm going to cheat a little bit. Let's see. My final answer would be, I found out that A was 2 and B was 9. So my final answer would be like right here, right? That this original 29X minus 5 over the 3X plus 1X minus 7 decomposes into this. All right, have a great day, pre-calculus students.